just eating. Yeah, eating's the same way. It's like, I guess I'm having more non-fat cottage cheese because, I don't have any cookies in the house, even though I want one right now.
So that is a good strategy and usually works. However, for me, for some reason, it did not work for the giant thing of sardines I bought from Costco.
Oh, well, come on.
Or anchovies. It was anchovies, not sardines. But I was like,
are they supposed to be healthy?
Dude, they're a fantastic snack. They're super easy, packed with protein. It's just, I don't know. There's something a little bit unpleasant about opening it up and seeing these freaking fish.
Welcome to the EmberMap podcast, where we discuss design and development in the world of Ember.js. I'm Sam.
I'm Ryan.
And today we're joined by special guest Tom Dale. Welcome, Tom.
Thank you guys for having me.
Thanks for coming by. So how's New York been treating you, man? You seem like you look good.
Thank you.
You only look 10 years older, even though you've only lived in New York for a year.
No, although sometimes I feel like the air is not good for my skin. I feel like I break out more in New York.
You're radiant, Tom.
Thank you. Well, I did moisturize this morning.
Oh,
I knew I was coming on to be on TV, so I moisturized. Yeah, it's great. There's like such an energy to the city, and I don't know, man. It's cool being in New York. I get emails from like Jeremy Ashkenaz and be like, hey, so we'll go have lunch in Bryant Park, or Rich Harris works on Roll Up. So I'm like, hey, you're like a few blocks away from me. Why don't we like hang out and get a coffee?
It is amazing how many people live here. I mean,
and people pass through too.
People pass through.
That's the thing I miss the most about Portland, is that it was a cool scene, but there were so many people that I didn't really get to see very much because they didn't have a reason to go to Portland for work. But I feel like so many people in tech in our community, whether they're coming to New York or like New York or San Francisco, are the two places people tend to be for business, for whatever that they need to do, or the places that you might go to visit friends
for fun.
Like that,
yeah, exactly. Well, that's great. So you've been working at LinkedIn for how long now?
It was just over a year because, I remember I did my interview the day after the election, which was the first interview I've ever done on literally zero sleep. So that was cool. So
were you in New York for the election?
I voted in the morning and got on a plane right after to fly out. So it's been just over a year, which is like a good amount of time to get some stuff done.
Absolutely. Like, I'm sure you've been working on lots of different things at LinkedIn. I know there's like a lot of Ember developers there. I'm sure there's lots of different projects going on. What's been the main focus of your work at a high level over the last year?
The thing for me that I've been most interested in is, I think Ember is probably the most productive tool for building web applications, but it tends to be best for things that maybe are like running on a desktop computer, or running for people who have broadband, or running what we might call like workspace applications, like a Gmail, where you log in and you're kind of just in for maybe not the rest of the day, but you spend half an hour using that app, Google Docs, Gmail, stuff like that.
That's totally been our experience.
And I think it's if you're building an app like that, it is, again, in my opinion, a little biased, but like by far the most productive framework for doing that, and probably the safest bet long term. Based on the track record of JavaScript frameworks, I think we're the only ones that have credibility here.
I mean, what we say sometimes is like Ember's been around for 6 years and it's going to be around for 6 more years.
Yeah, absolutely.
Yep.
And every time people start to count us out, be like, oh, it's like old. The industry has shifted too much. We always mix it up. Actually we anticipated this and here's the plan. So I think for me, the thing that has been most interesting is, I think that we are definitely not meeting the needs of people who need to deploy web applications for the mobile web, for like smartphones and maybe even tablets, and particularly in emerging markets like India and China. These are places where you have people who maybe have never even been on the web before, and now they're joining the web, and the way that they do that is through their smartphone. Right, so I think in the West, we tend to think of a smartphone as kind of this auxiliary device, but when you do real work, you do it on your desktop. Mm-hmm. But for a huge chunk of the world, that's just not true. Mm-hmm. And we need to meet those people's needs and make sure that we can deliver apps that work for them. The side benefit is, by the way, if you make an app that works on one of these crappy Android phones, it's going to be really awesome on your like
Right.
17-inch MacBook Pro or whatever.
Right.
Do they still make 17-inch
I don't
MacBook Pro?
think
I don't
so.
think they do. Yeah. So that's not your iMac
You
Pro.
dated yourself.
Your 27-inch iMac Pro.
There you go.
It'll really scream on that. So I think that there were just a lot of assumptions that we could make when we were targeting desktop browsers with broadband, that those assumptions don't really hold. You can't get away with them
Right.
on the mobile web. So I've been thinking a lot about like how do we build apps? How do we kind of how do we cut the fat? And it's tricky because you can trim the fat, and that's what people try to do. But if the problem is, well, you can't send, there's like some threshold of code that you can send, and then that's it, right? Like after a certain threshold, it's like, well, you're now out of code. It is too slow.
So even if you're a bright person, who knows how to design things well, you kind of have a budget, and so
You have this budget, and then there's not really clear guidance on like, okay, well, what happens after that? Okay, I guess we're done with the app. No more features, right? Like it's not going to fly.
Yeah.
I would get fired. I assume most people would get fired for being like that. No features.
yeah.
And to be honest, like that's doing a disservice to your users as well, right? Because you want to be delivering features that make their life better. And I talk to a lot of people who say, this obsession with load time performance and file size it's like a good conversation to have, but at the end of the day, I would rather have an app that's maybe a little bit slower, but
Right.
does more.
It's
right?
almost like we've already moved through the phase of having useful software introduced into our lives, and so now we're at a point where it'd be nice if it was faster.
Right.
But at the beginning, it's like having Excel or not having Excel.
Yeah,
is
give
what-
me Excel even if it's slow.
Yeah, exactly, exactly.
I mean, we talk about this all the time. Like, would you rather have double the revenue, but you have to double the file size of your JavaScript app?
Right.
And I think every owner of
like,
any company would say
obviously,
yes.
Right.
Triple the size
Right,
of my
right,
JavaScript
right.
application.
Yeah.
Even if you lose some people, but you get some big people
Yeah.
who are high value or something like that,
Yeah.
right? It's not.
So I think the trick is, okay, so maybe you can get away with that in the US, and maybe your whole business strategy is, well, let's bet on the fact that hopefully folks will get faster devices and faster networks. And I think that's a valid strategy perhaps. But I think realistically, if you are a bigger company and you've kind of reached market saturation in the US and you've reached market saturation in Europe, I mean, China and India, these are very juicy markets, So if you care about revenue, at some point, you're going to have to care about these markets, I think, if you want to continue to grow. And I think the thing that ends up being cool is there is also this massive shift happening behind the scenes, and I think people are starting to detect that something's happening, but it's not really obvious what a tidal wave of change is happening, which is that I've always described the browser as being kind of like this operating system. It's like a secure operating system that lets you download and run third-party untrusted code. But if you think about what an operating system does, and you think about what a browser does, there's a lot of similarities. Expose like APIs for accessing files. It exposes APIs for accessing
Hardware on the
hardware,
device.
like camera, memory management, all this stuff, right? Processes, web workers, and so on, networking. So all of that has kind of been coordinated with JavaScript historically, but we're moving to a world where you have primitives like WebAssembly that let you run things in a way that is much more literally like an operating system, right? Because now your code is giving instructions to the browser at a level. It's not just like allocate this variable and create an object. It's like allocate this slab of memory and put some bytes here and munge the stack in this way. That is kind of like a game changer. And I think for the context of the discussion we're having now about mobile web, emerging markets, et cetera, I think most people think of WebAssembly as like, cool, I will be able to run like Unreal Engine,
yeah.
Like
that's
great.
That's what I think about when I hear. Whenever
It's
I
like
hear
cool.
about
Oh, there's certain categories of things that require a high degree of computation, like cryptography, right, or like video codecs, and now we'll be able to run them at a speed that makes them realistic in the browser. And I think that is an important use case. But to me, the more exciting thing I think that will impact more people is that WebAssembly just simply parses and gets up and running much faster than JavaScript does. So there was that recent post by Lynn Clark from Mozilla where Firefox now has WebAssembly parsing faster than network I/O. So it will parse the WebAssembly that comes in faster than it will come in over the network, which means that it is effectively free. For all intents and purposes, there is no parse step because as soon as it comes in from the network, it's done.
Before it even finishes coming in from the network?
Right, so it's a streaming parser, and then as it gets a chunk of WebAssembly, it can parse it, because JavaScript is a highly contextual language. You can't actually start really parsing it until you have the whole file.
Okay.
But with WebAssembly, it's much easier to parse it in chunks.
Wow. So kind of taking a step back, so you were kind of making the point that we've been able to push modern hardware to its limits, and we can keep eking things out of it. But if you're thinking about China and India, if you're thinking about places that don't have high performance desktop computers, you have to think about another way to get a featureful app to these people, right? And so whether it's WebAssembly, whether it's using other static tools, bytecode instead of JavaScript, or all of these things, at a high level, is that kind of what your argument is? Like, there needs to be a shift in how people are thinking about how to evolve how we build web apps?
I think there needs to be a shift. I think that shift is happening now. We had to kind of bootstrap the tool chain ourselves, right? It's the web, it's open, it's freewheeling, and I think most importantly, and this is, I think, it's good, but it's also a double-edged sword.
With it, right?
Well, I would say there's just no one controls it, so no company is incentivized to invest in it in the way, for example, that Google invests in like the Android SDK and the IDE, or the way that Apple invests in like UIKit and Xcode. There's no equivalent to that on the web, and I think that's a good thing. But it does mean that we kind of have to bootstrap this toolchain ourselves in the open source world.
And you go in the wrong direction sometimes, and people realize that certain things don't work out.
Yep.
It takes a longer time.
And there's just a bootstrapping process, right? So the stuff that we can get away with now because we have very refined tools like Babel and TypeScript, and even I'll give a lot of credit to Webpack, because I think there's two strategies. One is you can make things faster in absolute terms, which is the stuff that like WebAssembly is good at. I think Glimmer is a good example of this. Of you kind of have a little bit of like a paradigm shift that lets you model it in a way that will execute faster, just in absolute terms. But then there's also a matter of being smarter about when the work happens. So instead of just dropping this, I'm going to handwrite all this JavaScript, I'm going to run this very naive script that just concatenates everything together. Maybe I run like this naive minifier. Okay, here's this big blob of JavaScript to run, and you're going to get all that JavaScript whether you need it or not.
And the only way you can make that faster is if whatever is responsible for executing the JavaScript gets faster.
So if all you want to do is make, like, here's this blob of JavaScript, please do it faster. Faster CPUs, faster networks, faster JavaScript engines. Those things help a lot. But you do reach a point of diminishing returns, I think, especially like in the US. It's hard to imagine smartphones getting like dramatically faster, right? And I think at that point you have to say, well, let's be smart about the order in which we send this code to the browser. Let's be smart about the order in which we do things. A lot of it is perceived performance too, right? So,
So I have a question. Kind of the way I think about this is like you have someone who just knows HTML and CSS, and they can write an HTML and CSS file and put it on a content server somewhere and serve it up. They're thinking at the top level, the thing that's the last thing to be read and rendered to the screen. And then as you go down, you have JavaScript, then you have these things you're talking about, WebAssembly, computer hardware. And, if you look at like a multi-year period where the hardware is getting faster, maybe what the people who are working up here are doing is not changing. So, you're focused on writing JavaScript, more efficiently, or not even more efficiently, but better design. You're thinking about JavaScript architecture, application architecture, or patterns or frameworks like Ember. But as these things down here start to change, my question is, what's the interaction there? So is there a time where, because these big things at the bottom go through large kind of they go through like if there's a new era of what's underneath, is that going to affect what goes on up here, and are people going to need to be kind of aware of it?
Well, I think it depends, and this is why, all things being equal, I prefer to use technologies, languages that are more declarative, less imperative. So the W3C has the document about the rule of least power, right? Which is basically saying that given the constraints, always pick the language that gives you less freedom to just tell the computer how to do things and just say what you want done. Let the computer and the system interpreting that figure out the best way to do it.
I remember you talking a lot about this a couple of years ago when I was first getting into Ember, and there was this question about, I need to do some function that doesn't exist in handlebars. Now I have to make a helper.
Yep.
And why am I doing this?
Yep.
And a big part of the answer had to do with this.
Yeah, and I think it's paid off.
Yeah, because that's what I was going to say. I mean, you have a whole population of Ember apps that had the rendering engine change underneath them.
And Ember has shifted 3 times now, right? So the first one was string concatenation, where you just concatenate these strings together, and that was kind of like that was the way things were done in that era, because DOM access in IE was so slow. So you had to concatenate strings because that was the only way you're going to get decent performance out of IE6, which seems like an insane constraint now, right? But it was true. That was the whole like in the iCloud apps, mobile me apps I worked on at Apple. Like the whole point was to run in IE7 so we could support Windows users. That was like the whole point of having these web apps.
Interesting.
So then, now IE6 and 7 kind of fade out, and now we have fast DOM APIs. So now Ember is able to switch to this DOM-based rendering engine, which has been really great for security, by the way. That's like, I don't think we've had any security issues, any security bugs in Ember since the move to DOM, which is like, so that from a security perspective alone, it was worth it. And performance as well. We shifted from string-based templates to then, now we're going to compile it into JavaScript, and the JavaScript is going to emit DOM. So under the hood, like the internals were completely redone, like completely rewritten, and yet your Ember app stayed the same.
Right.
And then now we have this third progression to Glimmer, where instead of just compiling it into JavaScript, which has, as we were talking about, like parse costs,
right?
We compile it into this bytecode. We basically say, oh, hey, it looks like handlebars is actually like a functional programming language. Let's write a compiler that treats it like a functional programming language, compile it into bytecode, kind of like how the Java compiler compiles Java into JVM bytecode. And that will parse much faster, and it also executes a lot faster. And it's pretty amazing to think that a framework from like 2011 can make it all the way now to 2018. And now we are on track to, at some point, have the internals of Glimmer be all written in WebAssembly, like a very low-level language, right? And if you think about your application when it comes to like startup costs, interaction, the vast majority of your time is dominated by rendering, right? Like, we download this JavaScript, we got to render something on the screen. That process of generating the DOM, figuring out what to wire up, that takes up the vast majority of the time you're going to spend, right? So it makes sense to
have
that
be able to be moved and have the APIs on top be something that can be just declarative and minimal.
Yep, and say like, here's what I would like to render based on the current set of technologies in the browser, on the web.
Right.
Do that in the most efficient way that you can.
It's super interesting because a lot of times we talk about declarative programming, and I like it because it lets me describe the states my app can be in.
Yep.
And I don't have to think about like, how do I go, especially if there's like 3 or 4 states, I don't have to think about all the transitions. I just have a template with a few if statements. But I'm not even thinking, like, when I'm writing application code, I'm not even thinking about how you're going to, in 2 years, completely change the rendering engine.
And to be honest with you, it's a hard argument to make to people unless you've been around to experience it.
Well, that was my question, and I was wondering if it was going to be a little bit of a tangent, but we're talking about, how the lower level stuff affects the higher level stuff, but the benefit of being able to change underneath the hood for 7 years, I feel like, is not something that's talked about. That's one of Ember's biggest strengths, and it's not really something that it's talked about, but it doesn't resonate the same way as, look how fast you can do this new thing with this new tool. And so one of my questions was going to be like, I don't know, what are your thoughts on that?
I mean, it's just it's a hard
just the
sell,
nature
right?
of the thing that the benefits accrue over years of work and research.
You don't know what's
going
to change, right? If you had asked me in 2011, well, okay, what I wouldn't have told you, oh, we're going to rewrite the rendering engine twice and we're going to be using WebAssembly, because the idea of WebAssembly didn't even exist. It seems so far-fetched in 2011. So it's like,
but
the only thing you know as a mature engineer, the only thing that you know is that change is this constant, right? So if you can optimize for those contextual changes, you can do a little bit better of longevity. And
there's principles like the rule of least power, which have proven themselves and are maybe good bets to place.
Right. It's like I can't tell you why it's going to be a good idea, but I know that if things change, it will give us power to react to them. And
every application developer knows that you want to write code that's easy to refactor, right? So like not even thinking of like the framework or anything, just when I'm working on my applications, I'm thinking about that. So I think you can sell this idea of
maybe. I mean, it's just if you go back and you say, like, okay, now take your Backbone app and port it to WebAssembly. It's like not going to happen, right? And it just doesn't make any sense. But
it's true.
But it's a hard sell. But I think it's okay, right? It's like the same reason I didn't like my mom telling me to eat my broccoli. It feels like it feels like an eat your vegetables argument. It's like you can't tell people like, hey, you know what? This is unpleasant.
You're going to need to refactor, and so you better set yourself up to be able to do it now.
Yeah, I think the way to do it is stuff like this, like Ember stability without stagnation, the longevity and the stability. Those are things, the RFC process. These are things that are a cherry on top, right? So it's like the Pepsi challenge, right? You got to make sure that first sip is sweet enough to get people to stick around. Otherwise, you need, it's stupid, but you persuade people with emotional arguments or not even arguments, but conveying that emotion.
I think another way to say this is that people do judge a book by its cover. And that's just, for better or worse, that's the reality of it. And so you want to be thinking about, when someone first hears about this thing, this idea behind this thing of yours, they see it on a tweet. What does it say? What is it like? Once they click the link, what is it like? And I think that's something that Ember could learn from the frameworks that have had the luxury of being created in the last couple of years, because those have had the benefit of seeing, they have a very modern design focused on onboarding, things like that. And so it's this idea of like progressively disclosing the power of what you're using, but the first touch point is fairly simple. And I think that's one of the parts that makes it hard for someone to start with Ember today.
And I think it's important to stay away from this mindset of like, they just don't get it. They're going to regret it. They don't understand. You can either
poo-poo what their experience as a first time with the framework is.
Because you can either wring your hands and say like, oh, they should really know. We need to educate them. They're acting against their own economic interests, right? The equivalent of that. But I think the reality is that
they had an emotional reaction, validate it, understand it.
And you can embrace that, right? If you believe strongly in these ideas, if you believe strongly in some of the ideas that I think underpin Ember in terms of like governance and so on, the best way to share those with the world is to build something that everyone's super excited to use and kind of just lead by example. Once they're there, like once they show up, you can kind of lead by example. Which is why I think performance is so critical, because there's nothing more visceral than performance. And another thing I realized is that humans are subject to many biases and logical fallacies, right? We all do it. And I think one of the most powerful is like availability bias, right? You tend to just like quickly sample what comes to mind when I think of this and what comes to mind when I think of this, and now I somehow compare these. You're not doing like a in-depth evaluation and weighting of all the factors, right? And the thing that's tricky is that because of that, people are really drawn to objective measures, because they'll say like, well, this thing's hard to measure, but this objective number is the best thing that we've got. So performance is very objective, right? You have a hard number, you can run a benchmark, it's statistically rigorous, it seems like, hey, this is a rigorous...
It's also really easy, right? You can just, in a day, compare a whole bunch of different frameworks.
And on the flip side, like how do you rigorously compare or measure productivity, for example? And the thing I realized is that the reason I've got such a bee in my bonnet about performance is I realized that if you are appreciably slower, you are always going to be on defensive footing. And now somehow, if I want to convince you that the productivity of the thing I'm offering is worth a performance penalty, now somehow in your head, you have to translate the abstract, fuzzy productivity benefits that I'm selling you versus the very concrete, absolute performance numbers. And you're just going to lose.
Right. Yeah, it's fuzzy, so you're going to be like, people are going to be able to convince you, like someone else might say, like, oh, there's actually not a lot of productivity. And you might be like, oh, okay, maybe there's not.
And you're like, okay, this thing is 1 second slower, so how much productivity units do I need for this 1 second? Like, it's just, you put people in an impossible situation to make the right decision.
Yeah, that's interesting. I might push back a little bit, and I think it also kind of depends on who your audience is.
Sure.
But, when I talk to friends of mine who aren't developers and they have their handful of homepage apps that they use, this is one thing I think that maybe gets lost in the web debate because what's the experience of users who aren't thinking about parse times, right?
Sure.
Or what's their experience?
Well, I mean, obviously Rails is popular, right? So performance isn't that important.
Well, I mean,
Rails is a good example, right?
But that is a good example.
Yep.
So if I have a friend who has, you need a budget app and they love it and they open it and they do something while it opens, but they don't care, because if there was an app that was 10 times as fast, it wouldn't matter because they love what's behind the loading spinner.
I think it would matter, right? Like, I think, of course, all things being equal, if you have the exact same app that loads in 1 second, one loads in 10 seconds.
But that's the thing, is that...
I think going back to his point, though, like you're about to start a new project and you're comparing all these things and you're not thinking about the guy in 2 years from now that's going to open the app and be delighted. You're thinking about the table with render times.
Right, the enterprise comparison table of your available things. Yeah.
I mean, performance is a feature, right? Like, there absolutely is a reality of, for example, like a project that I've been working on has build times that are like about a minute. Like, you save a file, run a build, it's like a minute. And
that
dude,
sucks. I mean,
I get so distracted debugging stuff. Like, I forget what I was doing a minute later, and maybe that doesn't reflect well on me. But at the same time, it's like the reality is, if I have rebuilds that are like under a second or two, my productivity is much higher.
Absolutely.
Super fast feedback loops.
Yep.
Here's a point I'll make. It's a false dichotomy, right? You don't have to choose. I think a lot of people. One thing that has really chafed,
grinded your gears,
has really grinded my gears, is part of one of the frames that people use when talking about performance, like web performance, has been about they kind of try to make it into a moral argument and say that you are valuing your developer productivity and your developer experience over the user experience. And I don't like that frame, because I think that they are not inherently in tension. And in fact, oftentimes the opposite. Oftentimes,
it's a ridiculous statement. Like, your users might love your app, even if it's slow. So it's saying you're valuing one over the other. It's just,
but I think, like, just having, as we were discussing, I think declarative systems tend to be more productive, assuming that the abstractions are right.
Right.
And those are also the things that are much easier to optimize over time. And I think that part of what we're doing with Glimmer and Ember and bytecode stuff is saying, hey, if you write code that is very declarative, that tells the compiler what you want to do, I think, first of all, writing code that is clear enough for the compiler to understand what you want to do makes it a lot easier for humans to understand what you want to do. But we can take that information and we can do some really smart optimizations with it.
Mm-hmm. So probably a good idea.
Yeah.
There's a strong argument there for it.
Yeah.
So we've kind of been talking about your work over the last year, between your and Yehuda's keynote last year, the progress we saw on Glimmer, where it is today. In the last month or so, we've kind of heard Yehuda talk about what his focus is for the next year, what he thinks the Ember community should focus on. A lot of it involves kind of pulling back from things that got away, like directions that they thought the framework was going to take, and maybe it turned out not to take. So there's this notion of like kind of cutting back cutting things that are half complete or not all the way done and focusing on a couple of core things. So I wanted to ask you, like, what do you see 2018 for Ember? What do you see, if you were talking to a room full of Ember developers at a company, and they were kind of interested in what it's going to look like for them over the next year? What?
So I think 2018 is going to be a really exciting year for Ember developers, because I think 2017 was also really exciting, but it was exciting because we were doing all this really far-fetched experimental stuff with like the bytecode compiler and Glimmer and TypeScript and decorators and all this stuff, right? And so it was exciting, but there was also kind of a sense of like, that's exciting, but how does that help me, right? And so I think what is exciting about 2018 is we've done the experiments, we have seen what works. I have shipped a production Glimmer app at LinkedIn, and the performance is like shockingly good. And now,
that's awesome.
But also, LinkedIn has a ton of Ember apps, like a lot of Ember apps, and a lot of people who know Ember. So now the question is, okay, we've done the experiment.
How do I get the fruits of your labor?
Yeah, like how do we upstream it? And I think there's always a tendency to think like, well, am I just like going to get like left behind? Are they going to like abandon Ember? And like Glimmer is the new hot thing. But hopefully at this point we have a track record of that is not really how we roll.
Right.
And I think it was important to unlock the experimentation, because I think one thing that happened in 2016 was we focused very hard on the stability without stagnation story, but we didn't have a strong avenue for doing experimentation. And if every idea you have has to go through this like RFC process, and how you do it in a backwards compatible way, and then it ends up like it wasn't even that important, or it wasn't the right thing, there's just there's like a high overhead to that, and it caused, and I think that led to a feeling
to innovation.
Yeah, I think people felt like, well, Ember's like falling behind, there's all stuff and we need to catch up. So Glimmer was kind of like, okay, let's create a laboratory where we can do these like wild experiments, see what
Skunk
works.
Skunk
works, yeah, there you go. Yeah, like Los Alamos, right?
Exactly. And then after it's proven, let's say, okay, now we're interested in this. Let's bring this back to...
Right. Because as we've been working, we've always had like it's not like, oh shit, now how do we bring this back to Ember, right? It's like, no, we've kind of been thinking as we go, what is going to be the vector to get this back.
Right.
So this is something that like Godfrey has been leading the charge on of upstreaming the Glimmer components back into Ember. There's been a really
super exciting,
a really awesome effort. So we diverged the Glimmer VM, like the API, a little bit while we were churning on working really hard on the binary bytecode compilation. And so Chris Selden, Robert Jackson, and an engineer at LinkedIn named Stephen Foote have been doing a really awesome job of upgrading Ember to use like the very latest like master Glimmer VM with all the goodies from Glimmer.js, and that is basically done. They've got the test suite passing, and they're just working through the few last bugs. And so that means that very, very literally by EmberConf, Glimmer.js and Ember are going to be sharing the exact same rendering engine.
Wow. So that represents a big merge from when they started.
Yeah.
And
this is like unification, and it's what will allow us to drop a Glimmer
component into
Ember components.
It's being rendered in the same engine. It's the same
they're
code.
just like small tweaks or configurations on top of the core rendering engine, and it's and Yehuda, I know, has kept this as a constraint during the design of the Glimmer VM has this API called Component Manager. The Component Manager is just like an object that effectively, the way I would describe it is it implements the public API of the underlying component. So you could implement, for example, an API that would be you could basically re-implement React component API in Glimmer using Glimmer component. The only difference is it would have to use a handlebars template instead of having a render method. But other than that, you could have state, you could have component did mount, little receive adders. The whole thing is very low-level primitive. So I think that'll be really, really exciting, this kind of unification. And I don't know, I think we're also figuring out how do we have a good way to keep that backwards compatibility without incurring costs for the folks who don't need it. So one of the initiatives that we've talked about a lot in the past, but is now actually in the middle of being implemented for real is Svelte. Svelte mode for Ember, which is...
Tree shaking?
It's not tree shaking. So tree shaking is like if you don't import this module, you won't get in your bundle. And that is something that we're also working on. But I would say tree shaking tends to work at the module level. But with Svelte, one of the big problems is deep in the Ember internals, you'll have some conditional, like if it's this old feature, do it this way, else do it this way. And that's the kind of thing that tree shaking can't really help you with. So Svelte is a way for us to annotate inside, in the internals, hey, this is implementation code for this deprecated feature. Here's this deprecated feature that...
Almost like Ember Assert when you're shipping it to production, it just gets completely stripped out.
Yes, exactly.
That's super cool.
So the guarantee that we...
I see. So it's similar in that you're using static analysis to strip out unused code, but tree shaking can't do it for this part of the code base just because it's too dynamic and it's not.
Well, it just doesn't know.
It's not part of.
Like it doesn't know. Like
it's not part of tree shaking.
Yeah. So it's the guarantee that we'll make to people is take your app, put it in a certain version of Ember, refactor it to make sure you get rid of all the deprecation warnings in the console, and as soon as you get rid of all the deprecation warnings, you can enable the Svelte mode, and we'll Svelte out all of the code for those deprecated features that you're not using anymore. And I think this, in combination with removing jQuery as a strict dependency, is going to... I think people are going to be a little surprised at how small Ember gets.
Interesting.
Yeah. And then the next step that is being actively worked on right now is to move the Ember object model to ES6 classes. And that's going to make a big, big difference, because I think once you get rid of the jQuery and some of this code for deprecated features, I think the biggest thing left is the Ember object model, because we implement our own mixin system, class hierarchy, etc.
And that didn't exist when Ember started, but now it does.
I would say it exists now in large part due to Ember and Yehuda marching into TC39. Because you have to remember, before Yehuda and others led this kind of revolution, there were no practitioners on TC39.
I mean, I've heard Yehuda say this years ago that this Ember object model is going to be the thing that could get classes in JavaScript.
Yeah, and to be fair, it's not like we were the only framework that had a class implementation, so I don't want to take too much credit for it. But
the idea of getting it upstream into standard ECMAScript was
And you see this too. You see Yehuda's involvement with decorators and modules and all sorts of stuff that we felt was an important part of the programming model when you're building applications and you're not just doing like DOM scripting.
Right.
That's stuff that we're starting to see in the language.
Right.
I have a question. If we go back to the merging of Glimmer and Ember into Ember, as like application developer, what does that mean for me? Like, do I change any of the way I write my components, or?
Well, we will introduce the Glimmer component API, but because you have the core rendering engine and then you have the component manager for Ember components, then you have the component manager for Glimmer components. There is a different API for Glimmer components, right? It's a dramatically modernized API. Just use ES6 classes. You don't have to use .get and .set. You just use tracked properties. This annotation via decorators.
You have the at syntax. You have no root.
Root element that you configure in the component. It's all the way that we describe it is in an Ember component, a template is inner HTML, but in Glimmer component, the template is outer HTML. So there's just some nice quality of life improvements in Glimmer components. But I mean, look, like the Ember component API as it exists today is going to be around for a very long time,
right?
Because there's just so many apps.
That's great, and I can slowly start to refactor.
Right, yeah. People will want to refactor. People will want to start using Glimmer.
It's not like in order to use Glimmer, I have to do all this work. I can just cool.
And I suspect,
until Robert Jackson writes a code mod.
Yeah, I was going to say. I mean, there's definitely there's a long tail of things that you'll probably have to do by hand if you do want to port. But I just want to convey, I hope people don't get the message like, oh my God, I have to rewrite all my components, because you should definitely not do that. There will almost assuredly be code mods for the simpler cases.
Right.
And then we'll keep this around for a very, very long time.
It's so great that you get to experiment with it in an existing app. You could just create a new component and just make it a Glimmer component and play around with it.
Yep.
Is there a case where like a Glimmer component would be a better use case than an Ember component, like inside an Ember app, or vice versa, where you should lean towards an Ember component?
I mean, I would say for new components, you should lean towards Glimmer components. And the reason for that is there are semantics that we have put in place. There's design decisions around the Glimmer component API that were done for performance reasons. So there are a lot of lifecycle hooks in an Ember component that we have to invoke for compatibility that in practice no one really uses. And in Glimmer, we just don't invoke them at all. And I mean, Glimmer components generally, so for example, if you don't have a backing component class, if you have a component that is just a template, we will super optimize that in Glimmer. So we don't create a backing class for you, and we...
Whereas an Ember component in memory class is created.
Yeah, we always create this class, And I think eventually what we'll be able to do is if you invoke a template, depending on how big it is and how many times you invoke it, just like in JavaScript VMs can inline functions. We will be able to inline a template, so it will get compiled straight in, and you wouldn't even have the cost of like invoking a component. It would just be splatted, inlined right into where you're invoking it.
Interesting. That's we were talking about this in the podcast last week. Miguel Cambra has been doing some work with build time, what he's calling build time components, which is an AST transform, because he helped rewrite Ember font awesome to basically be completely compile time, and so you incur no runtime cost and you ship no JavaScript. So that sounds like, is that kind of what you're saying?
Yeah, it's a kind of, I think a similar
If you had a
idea,
Glimmer component that was just a template, you wouldn't need any of the in-memory representation of it.
Right. Yeah.
That's awesome.
Just compile it in.
That's amazing.
And this is the advantage of having it's like a proper compiler.
Yeah.
I was just thinking, like, JavaScript is compiled language. Like, just feels like such a compiled language these days.
Right. So, and that kind of ties into what you've been talking about over the last 6 months in some of your conference talks, blog posts, where you're talking about how frameworks are they're looking more and more like compilers than they are APIs for interacting with like JavaScript objects, right? And we were talking about this last week on the podcast. I was playing around with writing an ESLint plugin and a Babel plugin, which both do AST transforms. Super interesting stuff. Like I don't have a lot of experience with that, and it seems like, again, based on your arguments and like where you see the frameworks going, like this is an important thing. This is going to be an important thing to kind of know and understand as someone who's building applications in this space. So I wanted to ask, like, what do you think is important to know if someone listening wanted to dive more into this? What are some of the most important aspects of compilers and static analysis that are good to learn about? And then also, how could they contribute or, learn more?
Well, it's definitely, it's been a learning curve for me because, didn't get a CS degree, never took a compilers or operating systems class or whatever in school. So for me, it's kind of been like getting thrown into the deep end a little bit, but
best way to learn sometimes. Yeah,
absolutely. And the cool thing is, like, there are so many great resources now. Like on the internet, there's so many tools and guides and books that will show you the way, But I think so. The way that it's probably easiest and most helpful to get started is, like you were saying, with a tool like Babel or TSLint that operates in terms of an AST or an abstract syntax tree. So a compiler, of course, has multiple phases. So for example, in the Glimmer compiler, we take a template, and the template goes into a parser. The parser generates the AST. The AST, this tree, is just basically like a machine representation of the source code that you typed, right? So it resembles the source code you typed, but it's in this object graph instead of a string.
A string. So if you had ds.hasmany in one line versus ds.hasmany on the next line, the string representation, those would be hard to differentiate, but once they're pulled into an abstract syntax tree, you can just say this is hasmany is an invocation off of a ds object, and you just know that.
So I think, that part is very useful because, one, there's a lot of great tooling around it. So you have, Babel is one of the more popular parsers for JavaScript. There are others like Acorn. You also have TypeScript compiler exposes an API for accessing in TypeScript, not just the AST, the syntax tree, but also an API for accessing type information, which gets like really cool.
Interesting. So that's going to be parsing. That's why TypeScript needs its own parser, because the input is different, and so it needs to understand the type definition.
Right, and it also needs to know when two classes in different files point at the same thing, right? So it kind of tracks this type information, and
Interesting.
And it also does a little like flow analysis, so it can see, oh, here's a variable called name, but I don't know what type it is. But then I see on the next line you say name equals Ryan, right? It's a string. Okay, this is a string, and now you have to actually go back and mark that thing that you saw before as being a string, right? So it goes deep, man.
Super cool.
Yeah,
Interesting.
it's very cool. So I was having fun. Like I said, this is like a new world for me. I've never worked in or adjacent to a type system or even the ASTs really. So over the weekend I was hacking on TypeDoc, which is this open source project for generating API documentation for TypeScript projects. And it was, it was really fun, right? Because it's like, okay, you have these data structures that describe not just the code, but then like the relationship between them and the types and all this information. And then, okay, well, how do we turn that, how do we try to generate like really high quality, readable documentation for a human? And it turns out, by the way, that having type information is super freaking useful. Like, how many times have you looked at a variable and been like, is this an object? Is this a type? And even worse in JavaScript, half the time it's like, well, it could be a Boolean, or it could be a string, or it could be an options hat, right?
Or undefined.
Oh, God. So you end up spending so much time going back and like, okay, tracing this flow in this code base you don't know, of like, okay, how did this get in here? And versus TypeScript, where you just like hover over the word and it's like, oh, here's the type.
That's really cool.
So useful. So there's a ton of stuff available. And I'm sure...
it sounds like maybe the best way is to just, find something that's motivating to you and then just dive in, because...
I feel like code mods are a highly motivating example.
Yep.
Which is, I think, those are the kind of thing where I really had to cut my teeth on the Babel API, because it wasn't... You can read it and be like, okay, I think I understand, but then writing a code mod really is a good exercise in forcing you to make sure.
What was an example that you did of a code mod?
The code mod in this case was, I wrote this RFC for the JavaScript module API, where instead of doing like Ember.component to use the global, you can import component from Ember/component. And obviously that's the kind of stuff that is just super annoying if you have to go rewrite your whole app to use from the Ember global to imports. It's such a rote task that it's not hard, it's just so annoying.
Yeah.
And those are the kind of tasks that are really well suited for code mods. Like, code mods like having a free intern, basically.
Right. So you wrote that, and then you can just run your entire app through it, and then it changes it over.
Yep.
Nice.
Yeah, I think we ran that.
I think we did run it too with update.
Yeah.
Hopefully
it
went well.
Yep.
So I wrote the initial spike, but a bunch of people fixed bugs in it. So if it worked well, I'll give credit to those folks, not me.
That's cool. Yeah, I think that, that's how I started learning about it, right? It's like we were working on one of our libraries, and there's an API that you can opt into, and I really wanted to show the user, if you're a hypothetical user of our library and you opt into this feature, you want to know at compile time whether you're using it correctly or not. I was like, why would we, we could try to monkey patch some global runtime thing so that when you hit it, it's like how you see a deprecation, right? It's like if you're using a deprecated API,
you don't see it until it gets called.
Right, but it would be better to just have a message from the compiler saying, don't call this anymore. Yeah. So it seems like that's maybe the way we're headed too. Like I wouldn't be surprised if more deprecation messages were that. It's simpler to just do it on the object, but if you can do it in the compiler.
The benefit of the compiler is, one, like you said, you get this like early feedback at the compile step, and you don't have to, pray
wait for a minute build, call it,
and like a customer sees this error because they're using an API, like that sucks. But I think perhaps even more importantly, doing it at runtime incurs a cost on every single person. But if you can detect problems ahead of time by looking at the AST, for example, then you can do that once at build time and remove that cost from the user at runtime. And to me, that's one of the coolest things. For example, when we integrated Glimmer the rendering engine into Ember. So when we like did the rendering engine rewrite, there were several features that we didn't support natively in Glimmer. And we could have said, okay, we're going to go in and we're going to add these extra features to Glimmer. But it was mostly syntactic.
Can you give an example?
So one example of this is with each with the each helper in Glimmer, it requires a key parameter. And the key parameter just tells the system if you have like a list of things, has it changed between renders or not. So if like you have a model with an ID field, if it moves in the list, you don't want to re-render it, you just want to move it.
Right.
So Glimmer mandates a key attribute or argument, but Ember doesn't, right?
Right.
Like for backwards compatibility, we can't just like break everyone's each loops in the template. It's not going to fly. So we could have just been like, okay, I guess we'll have to like go add this feature to Glimmer. But instead, Ember internally has a suite of AST transforms for templates that we run every time we compile your app. Most people probably don't even know this is true. But we will go rewrite your template from the syntax that you wrote into the syntax that is compatible with Glimmer. And so now we don't have to add a bunch of features or add runtime support for this. We just, at build time, transform it into
what it needs to be.
Yeah.
Wow, that's awesome.
So if I write an each loop without, I don't have that key parameter because none of my each loops do.
Yeah.
What does it get rewritten into, like key ID? Or?
I think it uses the index.
The index, I would imagine.
Yeah.
Okay.
Yeah.
Interesting. So it's a way to sneak. It's almost like, and you're really not looking at the code that you've written in some sense.
Right.
But I guess you
Yeah.
never
It behaves
are.
the same, right?
Right. It behaves the same.
Yeah. So from your perspective, it's like
You could really troll someone with this. You could.
Oh yes. Oh yes. Oh yes.
They're like, I don't have an undefined variable called foo right here, but you just added it.
You could imagine the good April Fool's Day joke, which is like have a random number generator, and like 1% of the time you like reverse identifiers or something, but it's different every compilation step.
Oh my gosh.
Like, good luck debugging that.
Yeah.
It's good. ASTs are good for mischief too.
Yeah, they seem like it. Yeah.
Did you use AST Explorer?
Yes, I found out about it too late.
Yeah.
I mean, I used it for the node in the path part, and then I would go back to my plugin and run the test suite and like deal with the node debugger, which I had a hard time with, and like setting breakpoints and reload. And then I realized right in AST Explorer, you can just click transform.
Yep.
And you can see, not only can you see the original source code and the AST, but you can also start writing an ESLint, an actual visitor, and then see if it passes ESLint, or you can write a visitor for Babel and see what the output result is. So that was amazing to me.
Yeah. AST Explorer, I think, is such a cool tool because not only does it support JavaScript and have like this native integration with Babel and ESLint, it has, you can go, so it's just like a website. You go in and you can paste in source code, JavaScript, TypeScript, handlebars. There's like a million different languages, and it just shows you a graphical representation of what the AST looks like. And it's a really interesting way, if you're not familiar with this stuff at all, even if you don't really know what's going on yet, you can still kind of like, it's like getting to see the Matrix, you know?
Right. Absolutely. No, it's so true. It's amazing too. And it's just like, also just how fast it is. Like it's that notion of like a reactive programming environment, or what's the word I'm looking for? It's like direct manipulation. Yeah. Where instead of do this and compile and then see, it's like when you're drawing, you know, you just have the pen and the paper. They talk about this. I think the creator of one of the an original iPad interfaces talked about how, you know, when you have a mouse and there's a disconnect between the input and the output, your brain does a translation step. But with the first touchscreen and you're dragging things, it's much more intuitive. It's much less required to process and hold in your head. And so it's like you were saying earlier, when you have a minute build time step, you have to load so much in your head and you forget it. But like something like as simple as this AST Explorer thing where you can move so fast, and it made me think like this is really what I want for my application development as well. Where it's like something that's immediate and direct manipulation of what I'm doing.
This is why I like the Glimmer Playground. I don't know if you've used it.
This, yes.
But Glimmer Playground is like, this is a Glimmer app I whipped up really quickly because I wanted to share examples with people. I wanted to see the output like of the compiler. And it was so annoying to be like, okay, let me create a new project and like open up VS Code and like run the compiler. Like that open up browser, the whole thing sucked, right? So if you go to the Glimmer Playground, which is linked to on the Glimmer website, it's like, so I just created this Glimmer app. And on the left, I embedded the same editor engine from VS Code called Monaco, which is all written in TypeScript. So it actually runs, this is like, get this for mind-blowing. It runs the TypeScript language server that you get in VS Code in a web worker. So you can be typing and you get the full TypeScript language server, like type checking, autocomplete. It's super freaking fast.
Why don't we just code in our browsers then?
Well, I think that is probably what will eventually happen.
Because then you have your app right there. Think about developing a component, like a UI component.
There's several of these now. There's like, what's the company? There's like, what do they call it, like SourceGraph or something?
For React, the storybook.
No. It's like a GitHub browser that uses the VS Code interface.
Oh, really?
So you can like just play with your code. You can get type information. It's pretty awesome, yeah. Just like point at a GitHub repo and you have VS Code in the browser browsing this repo. Because how many times, this is true for me, I'll be like poking around a TypeScript code base.
And you want to just pull it into your editor. That means you have to clone it and right. Oh, that's cool. Yeah.
It's pretty neat.
Awesome. Why don't we wrap that up then? That was a super interesting conversation. Thanks for coming by today. I know folks are going to love everything we talked about. It was interesting for us also.
Well, it wasn't too rambling.
No, that's exactly what we were looking for. So, thanks, Tom, for coming. And folks can see you at EmberConf in a few weeks. I know we'll be there. You'll be there too.
See me at EmberConf, hopefully. Yep. Hopefully I'm at EmberConf.
That'll be good. It'll be good for the community.
Yeah, it'll be good. Good show. Something's really gone wrong if I'm not there.
All right. Well, thanks for joining us today on the EmberMap podcast, and we'll see you next time.
Sounds good. Thanks, guys.
Bye. This podcast is sponsored by EmberMap.com, where you can find high-quality videos and blog posts made specifically for professional Ember developers. Sign up today to access all of our premium content updated weekly.